This is lesson 6.4 in college algebra, page number 555 in your book, Nonlinear Systems and Equations and Inequalities. What we're going to do here is we're going to do nonlinear systems of equations and maybe a little bit into the inequalities, but we're not going to go too deep into that in this section. So first of all, again, the name of the section is nonlinear systems of equations. So that means instead of doing a system of equations like this, and then maybe you have a 6x plus 2y equals 12, and those are linear systems of equations because when we graph we get two straight lines and our answer is the intersection there. That's our x and our y values where those 2 points or 2 lines cross. When I say nonlinear systems of equations, it means that I may get a graph of a circle and I may get a graph of a hyperbola, and what I'm interested in is where those intersect. Okay, so they're nonlinear, but I still get, in this particular one, 4 different answers. So that's what we're going to do in this lesson. So let's just go ahead and get started with example 1. And they give us x squared plus y squared equals 25. And notice with each one of these, or with some of these equations, when we have an exponent on one of the equations that is bigger than 1, we have a nonlinear equation. This here is the equation of a circle. Nonlinear, it is not a straight line. This one here, because our exponents are 1 and 1, one on the x, one on the y, it is going to give me a straight line. So what I'm going to have here is I'm going to have a circle for this equation and a straight line for this one, and what I'm interested in are those 2 points of intersection there, my x value and the y value, in order to get there. So that's what we're going to look at with this one. So how do we solve a system of equations like this? Well, we have a couple different options. We have elimination and substitution. Now, one of the tips that I give students when we're talking about solving this is when I have an exponent of a 2 on the y or the x, or both, and I don't have an exponent on the second equation, then I use substitution. You can't do elimination because elimination means we're going to multiply this whole bottom by something in order for this to be an x squared or this to be a y squared. So let's say that we multiplied everything by x squared, or I'm sorry, by just x. That would give me 3x squared, yes, but it also gives me 4xy equals 0. And now I'm trying to combine it with this here. Well, this xy does not combine with that at all, and we end up having a mess. So let's go ahead and use substitution, and that will make life a little bit more pleasant. So what we're going to do is we're going to take the simplest equation, the second one right here, and we can set it to x or we can set it to y. Doesn't really matter which one we do. So let's go ahead and set it to x. So let's take 3x and make that equal to 4y. And then we're going to divide both sides by 3. So x equals 4/3 y. So now wherever I see an x up here, I'm going to put 4/3 y in its place. So that's going to look like this. 4/3 y, the quantity squared, plus y squared equals 25. Okay, so let's move some of this stuff out of the way here. And that's our equation that we're looking at. When we square 4/3, we get 16/9, and our y just becomes squared, plus y squared equals 25. And when we add our two y squareds, this one plus this one, this is 1/1 or 9/9. So we actually have 16/9 y squared plus 9/9 y squared equals 25, which gives me 25 over 9 y squared equals 25. So not doing anything really difficult here, just a little bit different. So let's give myself some room here. And there's where I am still. Divide both sides by 25 over 9. And that goes away. And when I divide that, it really is y squared equals 25. And then we invert 9 over 25. Those cancel. And we get y squared equals 9, or y equals plus or minus 3. So now at this point, remember, we got for an answer plus or minus 3. So we have to go back to our original problem. So let's get rid of some of this work here in order to get this. And let's take it back clear up to this bit right here. X equals 4/3 y. Okay, so let's plug in our plus or minus 3 for y. So x equals 4/3 times positive 3, and x equals 4/3 times negative 3. So those cancel, and my x value is 4 when my y is 3. And this one here, this cancels. My x value is negative 4 when my y value is negative 3. So what that tells me is that for this original problem that's right here, remember I said we had a circle and we had a straight line. What that's telling me is that when I draw my graph, so let's say I've got my axis here, and I have my circle, and then I have my line. Then my line is the 3x minus 4y equals 0. My answer is where this line crosses the circle. This is at 4,3, and this point here is at negative 4,3. So that works right there as far as my graph is concerned. So that's solving system of equations when one of them is linear and one of them is not. Alright, well, let's keep moving along here. We'll look at another example. This is example 2 on page 558. We have x plus y, and that equals 5. And we also have y equals 3 minus x squared. Alright, so again, we have an x and a y here, and here we have an x squared. So we're going to have to use substitution again because we don't have an x squared or a y or an x squared up here. So we're going to go ahead and use substitution. So I know that for this problem right here, I can take 3 minus x squared and put it in here for y. It's already set up. So x plus, and I would suggest that you do this, put whatever y equals in parentheses, just because later on it could be that you've got a negative and it could be a mess. You know, in this particular one, we have a plus sign here, so it's not going to be an issue, but if this were a negative, you want more than just x minus 3 minus x squared. You want x minus the quantity. So just get used to putting a quantity sign whenever you substitute so that you don't have to worry about making any errors with your negatives. So I have, let's put this in the right order, negative x squared plus x plus 3 equals 5, which gives me negative x squared plus x minus 2 equals 0. Now let's factor out our negative here, and we end up with x squared minus x plus 2 equals 0. Okay, so we can multiply this whole thing right here times negative 1 in order to get rid of our negative, or to get our signs to change so that our sign in front of the x squared is now positive. Okay, so let's keep going here. We can't break it down into real quick and easy two binomials. So what we're going to do is we're going to use a quadratic formula to solve this. So when you use quadratic to solve this, you're going to get, I'm not going to go through all of it because you already know how to do that. You get 1/2 plus or minus the square root of 7 over 2i. That's what you're going to get for an answer. So now we have to substitute 1/2 plus the square root of 7 over 2i and 1/2 minus the square root of 7 over 2i in order to find our y value. So this is our x value. So that's where we have to move on the x-axis. So when we do this, let's go ahead and go clear back to our original problem. I'm just going to write the original problem over here to the right. We had an x plus y equals 5, and we had a y equals 3 minus x squared. So we had a parabola and we have a straight line. Okay, so now what we're going to do is we're going to take our x values and plug in here and find out what y is. So it's going to be 1/2 plus the square root of 7 over 2 here plus y equals 5. And when we do all the work for this, we're going to get as our y value, and I'm going to put it over here next to it here. Our y value then is going to be 9/2 minus the square root of 7 over 2i. So that's my y value. So there's my x, there's my y value. Now I'm going to plug the bottom one, 1/2 minus the square root of 7 over 2i, and I'm going to plug it in for x right here. And when I do that, I get 9/2, but this time I get a plus the square root of 7 over 2i for my y value there. So there's my x value and there's my y value. Now what you notice here is I have imaginary numbers in my answers, which means that I can't graph this, which means if you were to draw the graph, and I'll do that right down here real tiny, you've got your straight line, and then you've got your parabola, and it's going to go like that. And notice it doesn't intersect because these are imaginary numbers. The intersections do not exist. So when you get i's in your answer, it just means you can draw both of those graphs, but there's no point of intersection there. So, all right, so that's example 2. Let's jump to example 3. Example 3 gives us 2x squared plus 5y squared equals 39, and 3x squared minus y squared equals -1. Okay, notice what we have here. We have my x's are both squared and my y's are both squared, so I can get rid of my x's or my y's. Okay, so let's go ahead and get rid of our y's, because all I have to do then is multiply this times a 5, and I'm going to write my top number there just so it's right there where it needs to be. And let's distribute that 5. 15x squared minus 5y squared equals -5. Add those together. 17x squared equals 34. Fortunately, 17 goes into 34 twice, so x squared equals 2, and x equals plus or minus the square root of 2. Alright, so that gives me 2 values for my x. So I'm going to get rid of some stuff up here so I have more room. Always looking for room. Alright, so there's my original problem. We just found out that x equals plus or minus the square root of 2. Alright, so now what I'm going to do is I'm going to do some substitution. I'm going to take this bottom equation here, and I'm going to substitute the square root of 2 wherever I see an x value. So I've got 3 times plus or minus the square root of 2 quantity squared minus y squared equals negative 1. And so this squared, it doesn't matter if it's positive or negative, it's going to give me a positive 2 minus y squared equals negative 1. So I get 6 minus y squared equals negative 1. Negative y squared equals negative 7. Y squared equals 7. Y equals plus or minus the square root of 7. So this is what we discovered. When the square root of 2 is positive, we get a y value of the square root of 7. When the square root of 2 is negative, because we square it, it turns to a positive, and we also get the square root of 7. So we get those 2 points there. Positive square root of 2 gives me the square root of 7. But one of the things that I have to notice here is this is a plus or minus. So when I put in the square root of 2, I get the square root of 7. But when I put in the square root of 2, I also get the negative square root of 7. And when I put in a negative square root of 2, I get the square root of 7. And when I put in the negative square root of 2, I get negative square root of 7. So I get 4 answers here because my x value is plus or minus. So when I put in the plus the square root of 2, I got plus or minus the square root of 7. So when I put in a 2 for x, I got 2 y values. When I put a negative square root of 2 in for x, I got 2 y values. So that gave me 4 different answers there. So if you were to graph this, it would look something like this. An ellipse and hyperbola. So notice it crosses 1, 2, 3, 4 different places. Okay, so this is example 4 on page 561. And we're going to use the substitution because our exponents are different in the 2 different equations there. So let's go ahead and set the bottom one equal to y. So that'll end up being 3 over x. Now, whenever we see a y, let's put a 3 over x in there. So let's look at our top equation. This isn't as scary as it's looking. Let's go ahead and square the inside there. 9 over x squared. Distribute the 3. Okay, so at this point, look at what we've got here. We have a denominator. Now, whenever we have a denominator, a fraction, in order to get rid of the fraction, we multiply the entire equation by that denominator. And in this case, it's an x squared. So let's multiply the whole thing by x squared. And that gives me an x to the 4th minus 27 equals 6x squared. Alright, let's set it all equal to 0 and put everything in the right order. There. So that's what we get as our equation. So, as you've learned before, when you have like an x to the 4th, we're going to take it and say x squared equals u. So therefore we can write this as u squared minus 6u minus 27 equals 0. Okay? And now we can break this down into 2 binomials equals 0. So we've got a u and a u and a negative 9 and a positive 3. So now I know my u is 9 and my u is negative 3. So now I have to go back and switch it and find out what my x is if my u is 9 and my other u is negative 3. So that means that x squared, which is my u, is 9, and x is plus or minus the square root of 9, or 3. And I also know that my x squared equals negative 3, my u value there. So my x equals, or my x squared equals negative 3, my x equals plus or minus the square root of 3I, because of this negative. When I put a square root sign over it, it becomes the I. Okay? So there are my 4 x values, plus 3 minus 3, plus square root of 3I minus square root of 3I. And that should tell you right now that I'm going to have 4 answers. 1, 2, 3, 4. But because this one is imaginary, it does not count as far as where my graphs intersect. The only ones that are going to count are these two right here. So that means even though I got 4 different x values, only 2 of them are graphable. So I just moved everything up so we could look at our answers right here. And remember, way back in the beginning, in our original equation, we had xy equals 3, and then we changed it to y equals 3 over x. So what I'm going to do now is I'm going to take my x values here and my x values here, put them in here so that I can find my 4 y values. So if I use just 3, I get y equals 3 over 3, which equals 1. So when x is 3, y is 1. What about when x is negative 3? Y equals 3 over negative 3 equals negative 1. So when x is negative 3, my y is negative 1. Okay, so there's 2 of my points. How about when x is positive the square root of 3i? So y equals 3 over positive square root of 3i. Okay, now this is where it gets a little bit tricky. Let's take this I while we're here and let's put it in front of my square root sign. Sometimes that makes it a little bit easier. If I multiply by the conjugate, remember when you multiply by the conjugate, it gets rid of my I values, because now this becomes I times I is I squared, which is negative 1. And then because I take an I times a negative I get negative I squared, which is negative 1, with a negative sign on it, gives me a positive 1. So that gives me a square root of 3 times the square root of 3, which is 3. And I can cancel it with that 3 and get a real quick and easy answer here. So let's put the stuff down here. So I have negative 3i square root of 3 when I multiply across the top. On the bottom, I get negative I squared times square root of 3 times square root of 3 is 3. This turns out being negative 1, or a positive 1. So that means basically this can all go away because it's just a 1. So we just have that all over 3. Well, I can cancel this 3 and this 3. So now when my when my x is, I said I square root of 3, my y value is going to be I square root of 3. With this negative put on there. Okay? Now when I look up here and do the negative square root of 3i, and I take negative square root of 3i, let's see if I can make some more room here. So I'm doing y equals 3 over negative I square root of 3. And when I do that, I again multiply by the conjugate. This time it'll be a positive I square root of 3. That gives me 3i square root of 3 over negative I squared. Square root of 3 times the square root of 3 is going to give me just a a 3 there. This again is negative. I squared is negative 1. So that gives me a positive 1 there, so I can just get rid of it because it's just positive 1. Again, I can cancel that and cancel that. And this time I have a positive I square root of 3. So when my x value is negative, I get I square root of 3. So these are my 4 answers, but again, this is the only one that's graphable. And if I were to graph this, it would look like this. There's my x, y equals 3 right there. And here is my x squared minus 3y squared equals 6. We'll do that in white. Looks something like that and something like that. So notice what we have here. We have 2 places where there's an intersection. So those are my 2 whole answers, which were 3, 1 and -3, -1. But these other ones with imaginary numbers don't intersect because they're imaginary. And that's it.